Hello, this is a video explaining the physical processes of sliding and slumping. These are two types of mass movement, and they're really important when it comes to explaining why coastlines look the way they do. So, this is a photo of what you might call a landslide. That's what lots of people sometimes remember mass movement as, is a landslide, okay? However, the term that describes this type of physical process is mass movement, okay? Mass movement is essentially the movement of sediment downhill due to gravity. So if the sediment had become loose at the top of this cliff, as you can see it has, so you can see these are loose bits of sediment and sort of rocks that have rolled all the way down the hill. Because it's become loose and it's not supported anymore, that's why it has fallen downhill. That's essentially all it is. It's the force of gravity pulling that sediment downhill. Okay, so it's quite an epic photo as well. It was from the Norfolk coast. So let's test ourselves. Pause the video, and I'd like you to identify which is the correct definition for mass movement. The answer is A, the movement of sediment downhill due to gravity. Okay, so very quickly, before we move on to explaining these two types of mass movement, sliding and slumping, it's really important that we know all 5 physical processes because, like I said at the beginning, they help us explain the way particular coastal landforms look and change over time, okay? So pause the video if you want to have a go at this by yourself. I've given you some photos and images to help you identify these 5 types. Pause the video, or I'm just going to go through these one by one. So number 2, the little snowflake on the screen is giving you a little hint towards weathering. And this type of weathering in really cold conditions is called freeze-thaw weathering. Okay, so really importantly, this is the type of weathering that happens mostly during the winter along UK coastlines. And what happens is it weakens the rock by water getting into the cracks in, say, a cliff, the top of a cliff, the water freezing, expanding, and then melting again. And this process is repeated, freeze, thaw meaning melt, over and over again until the rock is weakened, okay? And that makes it easier for another type of physical process to happen, okay? So once the rock is weakened, it can then be eroded, okay? Now, erosion comes in 4 different forms: hydraulic action, abrasion, and attrition, and corrosion. Okay, so you should know 4 types of erosion. So the next 2 are the two processes involved that are remaining physical processes that we see in these 2 diagrams are really important in the process, the overall process of longshore drift. Now, if you watch Mr. Steele's video prior to this one, you'll remember that longshore drift is the movement of sediment along a coastline, okay? Number 4 is transportation. Now, the type of wave you can see in this cartoon is a constructive wave. A constructive wave has a strong swash and a weak backwash, and it deposits sediment onto a beach, okay? So that's constructive wave. And the final physical process, very importantly, is deposition. This is the dropping, a bit like this hand is doing with the sand, the dropping of sediment onto a beach by a low energy wave. And a constructive wave is a low energy wave. It doesn't have enough energy to erode, so it just drops the sediment onto the beach. Okay, let's move on. So, on to these two types of mass movement. Now, this type of mass movement looks quite similar to the one we looked at previously at the start of the lesson. Now, the way you can identify this type of mass movement is by looking for small rocks and boulders at the bottom of the beach, okay, bottom of the cliff, sorry, on the beach. So have these rocks rolled their way down the hill due to gravity and essentially ended up at the bottom, okay? This type of mass movement is sliding. So imagine the slope itself is a slide you get in the playground, and you rolled a tennis ball all the way down that slide, okay? So sliding is rock slides and rolls down a steep slope. That's all it is. So it could be really extreme, like this photo. It could just be a few rocks and small sort of rocks that have fallen from the top of the cliff because they've been weakened by weathering over time or during high winds during a storm, for example. So there you go. There's a diagram to help us interpret this. Little rock at the top of the cliff, weakened by weathering over time. Maybe a bit of water infiltrating the ground at the top of the cliff, freezing or loosening this rock, freezing for freeze-thaw weathering, and then loosening the rock. Ooh, we're getting a little bit ahead of ourselves. Great. So there's our little rock falls. Rock slides and rolls down the steep slope. So that is sliding. The next type of mass movement that we need to know, which is slightly different, and it's really important to remember that they are two different things. So it's really good in the exam if you can talk about and explain both of them in an 8-mark question like we're going to do in a second. Slumping is when a steep slopes get saturated with water. That means soaking up water. Bit like a sponge, gets saturated with water and then cannot hold any more. The steep slopes get saturated with water and sections of the cliff collapse in a rotational movement. Now, this word rotational just means a curved surface, okay? So if you'd rather, you could say that the cliff itself has a slightly curved surface, therefore, these big sections of the cliff, you can see where the water has infiltrated the soil, saturated it, and then it's slid down. Now, think in your heads, what kind of rock do you think this is? Looks like it's quite soft. It's very brown. One that gets saturated with water easily. You might use it in an art class. This is clay, okay? And it might be a little bit of sandstone in there, some other kind of pebbles, things like this, but this is clay. Now, clay is very easily eroded and soaks up water easily. So this is a kind of rock where you get this kind of mass movement, slumping. So let's move on to the diagram because this might help us understand a little bit more clearly. So here's our curved surface. You can see it's kind of like a slide again, where the soil is essentially kind of moving in a big chunk downwards. And you can see these sort of areas, it almost looks like steps, doesn't it? But these areas of the cliff have slipped downwards because they've become saturated with water. So it's almost like they're really heavy. They're being weighed down by the weight of the water, okay? So let's see if we can identify these two types. I'd like you to tell me which photo out of 1 and 2 is sliding or slumping, and then which definition is sliding or slumping. So you should have a photo and a definition for both types of mass movement. Pause the video and see how you get on. Number 1 is sliding. Well done if you got that right. Number 2 is a slumping. You can see that it's quite a curved cliff sort of plane. That's like the surface of the cliff. And all of this material has slumps downwards, a bit like slumping in your chair, okay, when you're a bit tired. Steep slopes get saturated with water and a section of the cliff collapses. That is slumping. Rock slides and rolls down the hill due to gravity. That is sliding. And I know they sound quite similar, but again, like I said, they are two different types of mass movement. Okay. Now, this is where it gets a bit interesting. We are going to try and answer this exam question. Now, I have all faith that you, A, are capable of doing this, and B, that we are practicing this skill to get better for it, get better at it for the exam. Okay, so don't worry if this is still doesn't come too naturally in terms of an exam technique. You will get better at it over time. Okay, now to start an exam question, you are going to, a bit like a doctor does, you are going to pick out key information from this figure to then explain how this coastline has formed to look the way it does. Okay. So you're going to say at the start of your answer, and this is a good way to start any kind of suggest question with a figure or an examine question. So examine is the command word, and then you can also use this for suggest questions. Okay. So at the start of all of your answers, you should try and say, I can see in figure 1 that, and this forces you to pick out evidence and immediately give that evidence at the start of your answer. We're then going to model it after we've picked out the evidence. So I am going to show you how to interweave the evidence you pick out, 4 pieces of evidence, into an explanation for an answer to this question. Okay. So the 4 most obvious pieces of evidence you can see in this photo are, in my opinion. Now, if you want to pause the video and do this yourself, please do. This is a good test of identifying what can you see in this photo that you can explain and you can discuss. Okay. That's all examine is. You're identifying, you're picking out key features from the diagram or the photo, and you're explaining them. Okay. So pause the video, give yourself maybe 2 minutes to pick out that evidence, or you can just take some notes or listen to the 4 bits of evidence I would use. So number 1, there is a headland at Z or Z. Okay, we can tell because it's sticking slightly further out into the sea. So it might be made of slightly more resistant hard rock. That's going to come into our explanation. The beach is wider at the bay, in the bay at Y. So you can see on the headland, the beach is quite narrow. But there's more deposition inside the bay. We're going to explain that as well in our answer. Slumping has occurred at S. Now it's slightly harder to see, but we're assuming that this area of land here has not always been at this level. That it's actually, as slumping is, it has it's slumped down due to the clay becoming saturated. And as I've said in the 4th bit of evidence, this type of rock is likely to be sedimentary because it is orange in colour. And that's just something to remember with sort of sandstone and clay, it can often be quite orangey. Okay, whereas granite and metamorphic rock, igneous rock and metamorphic rock can often be slightly darker. They have crystals. Slate and schist, which are 2 metamorphic rocks, are very dark grey in colour. Okay, Right, here we go. So I'm going to model for you guys the answer to this. If I can get off there. Da, 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 da. There we go. Great. Okay, I'm just going to make the little screen a little bit wider so you can see it a bit better. But hopefully that's a bit clear. There we go. Okay, so let's zoom in a little bit. What's it? Now, we need to explain what the coastline, the physical processes that have formed this stretch of coastline. So you're essentially explaining, why does it look the way it does in this photo? So we've got our evidence, okay? I'm going to start off by saying I can see in figure 1 that there is a headland at Z and a bay at Y. This means that, now this is my explanation. I'm going to write my explanation in green so you can see the explanation. Now we know what the evidence is because we picked it out, but I want you to see what it means to explain what that evidence is showing, okay? So this means that this is a discordant coastline where 2 types of rock face the sea. We're going to carry on explaining. The headland is made of hard rock that is more resistant to erosion and erodes more slowly, whereas the bay will be made of soft rock, meaning it will erode quickly. Now we need to present. We've done a nice bit of explanation. We're now going to present our second bit of evidence. Okay. I can additionally, let's make it black. Additionally, I can see that the beach is wider in the bay at Y. This is because, so I'm now explaining why that is. This is because the waves that hit the headland lose energy and become constructive waves. This means that, we want to explain what a constructive wave is. This means that they have a strong swash and weak backwash, meaning leading to, so a phrase you want to use a bit more often, leading to more deposition occurring. In the bay. Now, have a little stop and think now, because have we answered the question? Are we really directly answering the question? It asks you to examine the physical processes that have formed this stretch of coastline. Examine the physical processes that have formed this stretch of coastline. So we've mentioned a lot of different physical processes. We've mentioned erosion and we mentioned deposition. Okay, so we can try and get some more in. We can carry on. We don't need to use paragraphs in an exam in question. We can just carry on presenting our explanation. I'm sorry, our evidence and our explanation. Finally, I can see, keep using I can see. I can see at the front, in the front of the photo that the cliff is made of a rock that is orange in colour and is likely to be a sedimentary rock such as clay. Explanation. This means that over time, hydraulic action, getting some different physical processes, and abrasion will erode this section of the coastline quickly, leading to coastal recession. Coastal recession being the moving backwards or inland of the cliff, okay? Some more physical processes. Right, final bit of evidence is number 3, slumping has occurred at S. So we actually want to include a little bit of this explanation, join it together. This could also explain why slumping has occurred at S. When the rock, this is where we get our explanation of the physical process that we've learned about today. So slumping is a type of mass movement. The clay, during heavy rainfall, particularly in winter months, the clay would become saturated and a large section of the cliff has collapsed. Would become saturated, would collapse due to gravity. Now, I think we have plenty of physical processes. We've got 4 different types of physical process. We've got 4 bits of evidence in there. And we have really nice balance of explanation in green versus evidence. Your explanation should be the main part of your answer. Your evidence is important. You should have 4 pieces of evidence, but the explanation is equally important. Okay, I hope that has helped in explaining how to answer an 8-mark exam question. I'm going to just very quickly, bear with me. I'm just quickly move the question onto this slide so that you can pause the video and you can have a little read. If you had a go at that question by yourself, you could even have a go at it now, having listened to my answer. Might be interesting to see whether you've remembered some of that explanation. But I hope you found that helpful and that now you can explain what sliding and slumping is, and you can also have a go at an 8-mark exam in question. Okay, don't be afraid. It's all just about that evidence and explanation. Okay, examining what is happening in the photo. Okay, take care. Hope you found the video useful and see you soon.